Plansifters. When grain or grain materials are processed through the various grinding machines of a mill, the resulting crushed material consists of a range of particle sizes. Sifting is the process by which this crushed material is separated by particle size into precise size classes. In this chapter, you will learn why Plansifters are the most used type of sifting machine, how Plansifters are constructed, how the stocks are separated, and how to change screens. There are several different types of sifter designs, but the most important type of sifter in wheat flour milling is the Plansifter. And the most common type of Plansifter is known as the square sieve type or stack type Plansifter. Plansifters are an integral part of any wheat flour mill. They are the most effective way to separate ground mill stocks. There are a number of reasons for this. They provide a large sifting service within a small footprint so that they don't take up too much space in the mill. They have a low power consumption. They have a gentle sieving action which gives cleaner flour. They are easy to maintain, and they have the ability to make numerous separations in a small space. This is a Henry Simon Plansifter from Sataki. Each Plansifter is made up of two sieve boxes arranged symmetrically either side of a central frame. Each of the sieve boxes on either side of the Plansifter is divided into compartments, with between 2 to 5 on each side. Within these compartments are the square sieve frames stacked up on top of each other. Hence the name square sieve type or stack type. A compartment will usually contain from 20 to 32 frames depending on the height of each box. These are clamped down from above, as well as clamped from the side when the door to the compartment is closed. This prevents the frame from being thrown out of the machine when the Plansifter is turned on, and also prevents stock from leaking outside the channels. Most Plansifters hang from cane or fiberglass rods which are attached to the roof. Contained within the central frame are counterbalancing weights that cause the rotational motion of the Plansifter. Adjusting the speed of rotation and alignment of these weights affects the speed of Plansifter rotation and size of the oscillation, in this case 72 millimeters. This laboratory scale sifter moves with the same kind of motion as a Plansifter, and the sieves are also arranged in a stack. However, sieving with this sifter must be done in a batch-wise manner. If a larger quantity is sieved, the sifter must be stopped, the sieve emptied, and the sieve stack reloaded. This is not required with Plansifters. Plansifters sift the stocks continuously using channels built into the sieve frames. If holes are cut in the lab-scale sieve frames, channels can be created that allow the stock to flow out of each section continuously, leaving room for new stock to flow in from the top continuously. In the same way, the stock continuously flows out of a commercial Plansifter from the bottom, leaving room for the stock to flow in from the top. The frames contain a screen of specified mesh size and sieve cleaners to help keep the screen from becoming clogged with flour. As the Plansifter rotates, the sieve cleaners jump around and knock against the screen above to keep it clean, Some screens are made with a wire backing under the screen for the sieve cleaners to rest on. Other styles do not have this wire backing. The sieve cleaners sit on the metal plate under the screen so that they can both keep the screen above clean and at the same time clear the fine material off the plate itself. This particular commercial scale sieve frame is designed so that any large material that overtails the screen will travel towards a channel that directs the stock onto a screen below. There would be another frame sitting on top of this frame, whose walls would prevent tails from falling over the sides. As this is happening, the fine material that passes through the screen lands on a metal plate and travels along the metal plate to a different channel. If the first screen did not have a large enough surface area to sieve out all the fines, then the second frame, with a screen of the same mesh size, could be placed below. The large material overtailing the top screen would land on the bottom screen and have to pass over twice the sifting surface. There are various types of frames that direct the flow of stock in different ways. For example, the type we have used so far channels the larger overtails over the top and the finer throughs to one side. In both cases, the stocks are directed to channels inside the footprint of the frame. Another example is this screen that allows the fine material to pass straight through the screen. The coarser overtails pass to a channel outside the footprint of the frame. These outer channels are made between the outer walls of the frame and the inner walls of the Plansifter compartment. Using a combination of clever frame and channel design, the stock can be sifted in various ways. This can be illustrated using a flow diagram where the squares represent sieve frames. Some designs will provide a large sifting surface with only a few separations to ensure that all of the fines are sifted out. Others will provide more separations but with less sifting surface allocated to each. If one of the screens in a stack of frames need to be replaced, the Plansifter will need to be stopped, the door to the compartment opened and the clamps loosened. The stack of sieves can then be unpacked to allow access to the screen in question. Care must be taken when reinstalling the frames that they are put back in the correct order and in the correct orientation, and that they are securely clamped from the top and sides before restarting the Plansifter. Another common type of Plansifter is the drawer-type Plansifter. Drawer-type Plansifters differ to the stack or square type in that the frames are not stacked directly on top of each other, but slide into slots. In addition, the frames may not be square in shape. This makes them less compact, but means that if a screen needs to be replaced, it can just be slid out instead of unpacking all the frames above it. This chapter has covered why Plansifters are the most used type of sifting machine, how Plansifters are constructed, how the stocks are separated, and how to change screens.